Hi everyone, this is Shiyu. Welcome to my presentation for the final project of the Cross Data at Scale. My topic is to design a NoSQL solution and system designing for coffee bean quality monitoring system. This is the content for today's presentation. First, I will give you some background about coffee industry, why I want to design a solution for coffee, and then we will review the database solution together. And the next part is to show you guys the system I designed, the whole system solution I designed for this project. And the next part is about the anticipate result we plan to see after the system deployed. And then we will take a look at the alternative approaches. And the last part is the summary of this project. Before we talk the NoSQL solution and the system, I want to talk why I choose coffee bean as my project topic. Most of us drink coffee. Americans consume more than 3 cups of coffee every day. Over 2 billion cups of coffee are consumed daily for the whole world. As we know, coffee is made from the coffee bean, and coffee bean is the processed coffee berry. Finally, berry is from the coffee tree. Because the popularity of coffee bean as a major crop and a commodity also supported economic development of many countries in the tropic region. The figure 1 shows us the coffee bean production keeps an increasing trend with a little fluctuation. However, the price in the figure 2 shows a dramatic fluctuation. Many coffee trade companies have their own coffee farmers, but most of the coffee beans are produced from the family plantation. Price is the most important affect income of the coffee farmers. So the situation is the price changed a lot. Why the price has changed so much? Coffee bean quality is the top factor. The non-human factor that directly affects the quality of the coffee bean is the growth environment of coffee trees. Basically, coffee trees grow in the tropics with rich soil. Little change in the temperature and the humidity have an impact on the quality. Furthermore, the coffee trees cannot be automatically planted and harvested like other crops. Coffee berry is generally harvested by hand, either by stripping all of the berries off the branch at one time or by selective picking. Although the coffee trees like tropical weather, global warming is killing the coffee trees now. Climate changing affects both the coffee bean quality and quantity by the higher temperature, moisture, and raining. This is the problem that by this project want to focus on. We want to improve the quality of the coffee beans by monitoring coffee plantations nearby, increasing the income of the coffee farmers. So that is the background of this project. If we want data to influence the decision making, we should give a data solution first. So let's look at what data sources are. First is the data collected from the plantation. We will deploy a sensor to collect the climate data except for the species and the yield. We didn't find a public dataset about this kind of data related to the coffee tree and also collected by sensor. So we designed a monitoring data dictionary with the reference about influencing factor. Let's take a look at the screenshot. So that is the screenshot for the dictionary, and we contain 3 types data: the name, data type, and the definition of the attributes. So we can see in there we have a location, the climate data, and also the species and yield. We plan to purchase the integrated sensors to reduce the number of sensors deployed in a plantation. The initial value of the data collection frequency is the hourly collection, and user can change it in the experiment. The second data source is the coffee bean rate from the professional organization. The International Coffee Organization defined the rating process and the scoring criteria, and the file was updated in August 2018. The grade dataset in this project is designed by the National Quality Standards. Figure 4 is the screenshot of the grade data dictionary, and we contain the attributes name, dataset, and the definition of the attributes here. This part of data needs to be manually inserted after the user gets the score report. We figured out the data source and the code book. The next step is to design a database. The NoSQL database solution we choose in this project is a white column store. The white column database uses the key to identify each row and store each column separately. It uses table, row, columns, but is different with a relation database. The name and the format of columns vary from row to row in the same table. It uses a table to store the value, but the relation among the attributes are released. In addition, the store resources are also reducing when a single column needs to store a huge amount of data, so we don't give all the space for the other rows like in a relation database. The capability of the handling a large column of data is one of the reasons we choose a white column store. It also shows the great performance in handling time series data, which we will use in the analyze in the future. Several open resource employee white column store include the big table from Google and the HBase. Here is an example from the project from the data from our data dictionary to show how we define the data model in this project. We use a sensor key as a row key to identify the column, and all the attributes will be divided into 5 column family based on their meaning. So for example, all the soil related data will belong to the column family soil data. And also the timestamp will store with the value in the table. After solving the database design, let's have a look at the system design. The purpose of this project is to provide an overall database solution and a monitoring system design for the coffee tree plantation monitoring and the data analysis. Based on the purpose, we require the system should provide several functions: automatic data collection, data store, real-time alarm, and generate analyze report. There are many precision agricultural equipment could be found in the market. The project assumes that the budget is sufficient so that the sensor will be fixed in one location, and the ID of the sensor could be used as the column key. If the budget is not enough, so the data could be collected by manual mobile sensors in the real-time case, and the collection point could be used as the key in the database. We have solved the database, so let's have a look at alarm system. So for the sensor, after they collect the real-time data, they should send the data to the alarm system first. It will be a threshold set by the user, and if the value is not in the range, alarm will be sent to the user's device as soon as possible. So for one time in a day, for example, like the 12 o'clock at night, the sensor will send the whole data collected in the past 24 hours to the database and process it and store it at there. So that after that we can get the clean data, and the R or Tableau could use the clean data to design a weekly, daily or a monthly dashboard or report and send it to user's device. There are two results we hope to see after this system is deployed on the plantation. One is to send alert information to user's device when the collect data is not within the threshold range, and the second is to provide a daily or weekly attributes trend dashboard. So figure 8 is an simulate example. Without this system, the farmers can only rely on the memory and the previous experience to make the decision. We hope this system could provide more details, attributes, change trend, so that the coffee farmers can find the direct buyers to make the reliable judgment. Microsoft Era could be an outstanding alternative approach for this project. It is a cloud service platform, and the data storage relies on a white column store. Many white column stores like HBase, which is free, which is an advantage for this project. This project combines a database and a visualization tool now, but in the future, the final goal of the system is to promote the transition from experience driving to data driving. As a result, more application and function will be added to this system. If the farmer or the company has a sufficient budget, it will be more convenient to purchase a serious error service instead of organizing the open source by themselves. Coffee as a daily drink promotes the prosperity of the coffee trade. This project built a system that includes a white column database, an alarm system, and a visualization system to help coffee farmers monitor and improve the quality of the coffee bean. The design of the database can support a large amount of data expansion. The data visualization function allowed users to see the information they want to refer and could show the trend clearly. Although we can't change the way coffee trees are grown in the context of climate change, a data-driven decision-making system allows coffee farmers to make more precise decisions so that the price of the coffee bean could keep an increasing trend, and also the income of the coffee farmer could be increased as well.